As we continue through the discussion of the internet, there's two topics that can emerge in your classroom. One deals with issues of privacy and also cryptography. So these things also intersect other areas, from the internet to global impact, algorithms, and these provide a context for discussing multiple big ideas. But in this course, we're going to talk about these in the context of the internet. Also on the slide you see right now, this is a Tech News article from last year that I introduced to my class at about the time when I discussed this content. And it was a celebration of Ada, and she's known by many as perhaps the first programmer. So we'd always, in our recruiting efforts, mention to some of the young women in your school that the first programmer was a woman. And she worked with Charles Babbage, and her father was the poet Lord Byron. She was friends with Charles Dickens and Michael Faraday, and lived a really interesting life. So this was a link that had some discussion about her life, and it was just something I discussed in that context. So think about these kinds of things as they emerge, history and other ways that they might interact with your course. So the next 2 or 3 slides deal with topics related to bits. These things could have been discussed also in Unit 2 when we looked at bits and bytes, but I'm putting them in this particular context because they have some issue of privacy or ways that privacy or things that are supposed to be hidden can be revealed. So in this first slide here called Bits Behind the Scenes, this is when there was actually an international incident involving someone who was killed by the U.S. military, and a report that followed up from that, and a redacted set of comments that was made on a digital file. And those who made the digital file actually just went in and used Adobe and drew black highlighting marks over top of the words, which were easily removed and revealed the rest of the content of the document. So we're not asking you to read Chapter 3 of Blown to Bits, but this particular incident is described very well there, and just an example of not understanding how digital information is stored or used even by tools can lead to national incidents, international incidents such as this. Another particularly positive way in which misunderstanding of tools can lead towards some kind of lack of privacy can be found in the story of the BTK killer. So if you've ever heard of this story, there was an individual named Dennis Rader who was a serial killer who over a 17-year period murdered 10 people, and he was arrested in 2005. And the actual account of how he was arrested and what led to his arrest is very interesting in its context. Because what Dennis Rader did is he would send taunting messages to the police, and he would even send like a floppy disk to them with some kind of message about his murders and how he was not going to be caught and such things as that. And he was not aware of the topic of metadata. So storing data about data, or in this case, Word storing information about who owned the license of Word, or who actually may have edited a document. So on this slide, if you watch the video that's linked here, around the 36-minute mark and the 40 seconds of that, there's a description of how they discovered Dennis Rader. And here's a type of hex editor that we looked at before that revealed some of the topics or contents within the Word file. And you can see where the name of his church is mentioned there and someone named Dennis. So all that the police did to find him is they took the floppy disk, looked through this forensic information, and located the church and asked if there's someone named Dennis there. And then they had their lead to catching a serial killer who had murdered over 10 people. So these kind of issues lead into the general discussion of privacy. So privacy is a vital topic of CS principles and occurs in several places in some of the essential knowledge statements. And you may want to throw out different kind of thought questions to your students about issues of privacy. So you could use cooperative learning techniques to break students up into either some kind of round robin or rally robin approach, or some way that's going to engage them in discussion, and just ask them to think about in their daily lives what issues of privacy might emerge when they're dealing with digital information. So some of the things that they might come up with are on this slide, and these slides were actually adapted from another talk by someone else that's referenced on the course. So some of these were reworded and added some additional details, But things like issues of preventing yourself from being hacked, espionage of some sort, protecting your email, making sure intellectual property that you might develop is secured, and issues of liability, privacy on the cloud, and just the general insecure nature of some technologies, and the whole paperless society that's driving this. So these are things that you could throw out as prompts and ask your students to begin discussing among themselves and sharing different thoughts about how the impact of privacy affects them in their daily lives. And so we could then enter into how do we protect things that we want to keep private. If I have a document or I have an email message or I have something that I don't want others to see except a certain participant that I'm sending to, that would lead us into a discussion of cryptography and different kinds of encryption discussions. So in this slide we can see a history of cryptography, and clear back to 50 BC. Caesar cipher is a well-known cryptographic technique. Cipher disk is similar to what we might have found in a Cracker Jacks box, that we turn a certain dial and it links up a certain letter to another letter. Military uses of encryption and to secure private messages in the Civil War. We mentioned earlier Alan Turing and the German Enigma machine. Navajo wind talkers who were able to secure communication during World War II. Claude Shannon is a name that we should remember before about bits in terms of information theory, and discussions of private key and public key cryptography that we'll cover in the next lesson. So some of the basic terminology that we want to cover when we discuss encryption and cryptography. Cryptography itself is all about being able to take documents and share them secretly over some kind of public communication channels. That could mean broadcasting a document or placing the document within the flow of many people who can look at it with their own eyes. So the idea is to take a document and encrypt it with a key and then be able to decrypt it with another key so that the knowledge of the document is known to either the originator or the person receiving the document. And the word cryptography, as shown on this slide, comes from two Greek words meaning secret and right. So cryptanalysis is the idea of going in the reverse. So given a encrypted document, trying to find the encryption key from that document. So this is a source of puzzles and newspaper article kinds of, if you ever look at a puzzle section of a newspaper, you can see these things trying to solve some kind of cipher. And then cryptology is dealing with both the ideas of cryptography and cryptanalysis, and a crypto system is a computer system that is able to encrypt data so that you can securely transmit or store information. Some more terminology that we need to understand is the notion of a plain text. So that's just the document in its natural original form. So something that's very easy to read and has no secret being hidden. So it's open to all to read. And then the ciphertext is the result of taking the plain text and applying some form of encryption to get a version of the plain text that's not readable without knowledge of the key. So some of the notations defined here on this slide, we'll call M the message, C is the ciphertext, E is the encryption, and D is decryption, and there's also a K for the key. And so if I take the original message and encrypt it, I end up with a ciphertext. So E with the M as a message, I end up with a ciphertext, or I may pass in a key as well with the message and encrypt that to get a ciphertext. And then if I decrypt the ciphertext, I should have the original message back, or if I pass in the ciphertext and a key, I should get the original message back. So obviously some property identity for if I encrypt the message and then immediately decrypt it, I should get the original message back, as shown at the bottom of this slide. So there are some cool applications of cryptography. So this is not exactly a cryptographic technique, but steganography is very interesting to discuss, and your students might find this interesting. So it's the idea of hiding some kind of secret message in an ordinary document. And encryption per se is not used, but being able to hide one document inside of another in a clever way can make the information unknown to those who aren't aware that it's being hidden. And so the idea also is to not increase the file size or alter the original document in any way that can be observable. In a typical way that we've done this, and we've had students work on this problem even in high school science fair projects, is to be able to hide messages inside of an image. So as shown on this slide to the right is the breakdown of pixels according to the red, green, and blue colors and the bit patterns. So in steganography, if I can take, for example, the red color and just pull one bit out and be able to alter that, and if I know there's millions of pixels in an image, I have access to over 1,000,000 pixels that I can then use to encrypt. And the beauty of this is that even though I have altered 1,000,000 pixels, or I'm sorry, 1,000,000 bits within those pixels, the human eye cannot discern the difference between the original image and the modified picture. So I'm able to hide things in a picture without them being detected. So for example, I borrowed this slide from another presentation from someone, and the idea here was to take this picture of a polar bear and hide it within another image of an aircraft, or vice versa. So the ability to hide one image within another, or hide text within another image, or even with sound. So if I have an MP3 file, I can just take 1 byte out of each second and use that to represent some characters and be able to spell a message out across a song. And that 1 byte will not be discernible to anyone's ear. So this eye trick is kind of related. It's not exactly steganography, but it was an interesting trick that I saw. So if you look at the photo of the woman on the right, and if you stare at the red dot intently for about 30 seconds, and then immediately look at a light source after that, you'll see the negative effect and see the actual photo of this Indian actress. So this is kind of like hiding within a negative, this kind of eye trick. But in real steganography, we're manipulating bits in order to hide images. The concept of watermarks and digital watermarks is very interesting. So the idea with a watermark is that I'd like to be able to stick some information in a digital artifact, for example, an image or a photo or a song, so that I can prove that I'm the owner of that. So if someone violates a copyright or someone uses my intellectual property in a way that's not approved, I have a way to come back and show that that original piece of art or song or whatever originated by me. So I can hide some encrypted text within the actual piece of artwork, and then after that's been copied around the bit, I can then prove that that's mine by being able to go in and pull out from that artwork a message that shows that I'm the originator or author of that. So this is an introduction to privacy. There's many more things that you could say to your students, and several different class exercises and activities that you could do to get them motivated in discussing this. In the future lesson, we will talk more about encryption, and in particular we'll look at the idea of public key cryptography and what it means to be able to encrypt information using different kinds of keys.